Hello info person, this is Anton, and today we're going to be discussing yet another unusual radio signal that right now is extremely difficult to explain. And specifically, we're going to be discussing this mysterious signal that essentially challenges our fundamental understanding of what produces these signals and how certain stars potentially live and die. And that's because here we have a very strange signal repeating every 36 minutes, and it seems to be coming from somewhere where there's basically nothing there. But more intriguingly, whatever this was, it was only doing so for a relatively short time before shutting down completely, which of course makes this an extremely interesting phenomenon. But just so that we're clear, right now, nobody thinks this is extraterrestrial intelligence or any kind of alien life. This seems to be natural and seems to resemble a lot of other similar signals, such as the famous pulsars. Except that when it comes to pulsars, the way they blink is a lot different and involves physics we actually do understand. And so let's talk a little bit more about this particular discovery and find out what's possibly happening here. But I guess let's start with pulsars. And so these are neutron stars that usually spin pretty fast, sometimes several hundred times per second. But at the same time, because they also have these powerful beams moving in two directions, sometimes those beams head toward us, producing very specific emissions resembling signals that blink several hundred times per second. But recently, astronomers have also discovered an extremely different type of a signal referred to as an LPT, a signal that should not even be possible. And here we have a radio emission that pulses once every few minutes or even hours, and does so in a way we've never seen before. And so here these are known as long period transients, and it's essentially a relatively brand new discovery that we first discussed just a couple of years back. I think the video should be somewhere in the description. And the problem here is that, well, nobody actually knows how this is even possible. And that's because if we compare this to pulsars, whatever is happening here seems to involve a completely different mechanism that currently nobody can explain. And so once again, for neutron stars or pulsars, here many of them start to act like these cosmic lighthouses, spinning rapidly and beaming radio waves toward Earth. But as they age, they usually start spinning slower and slower, and eventually reach a point astronomers refer to as the Death Valley. Or basically they start spinning so slow that they just don't have enough energy to produce radio emissions anymore, and essentially kind of run out of juice. And this normally happens when the rotation becomes at least a few seconds long. And so because of this, a pulsar whose rotational period is in minutes should be technically impossible. Yet now, for the past few years, quite a few have been discovered, and while none of them right now make a lot of sense. Because here once again we have powerful radio emissions, but also incredibly slow rotations. And while just a few days ago, researchers found another one, ASCAP J1424, once again discovered by the Australian Pathfinder telescope in Western Australia, that once again possesses some unique features. For example, here the periodicity is exactly 35.79 minutes. In other words, the signal here arrives to us almost exactly every 36 minutes. But unlike previous sources, this was only active for approximately 8 days before completely turning off. And when scientists tried to find it in some of the archival data, by basically looking at data years and years back, they found nothing. So basically here, this was only active for 8 days and then disappeared. And on top of this, the subject also seems to emit 100% polarized light. In simpler terms, it means that radio waves seem to be vibrating in a very specific organized way, as if they pass through some kind of a highly magnetized environment. And so whatever seems to have emitted this must have contained a very powerful magnetic field. But even though the researchers looked at all kinds of archival data and even conducted a new search using Gemini South telescope, here in this location they found no optical, near-infrared, or radio counterpart anywhere. And it's the lack of the visible star that makes this extremely difficult to explain. Because we would expect at least something here, such as once again maybe a neutron star, or maybe some kind of a white dwarf. But as I mentioned, obviously this is not the first unusual object, and quite a few extreme ones have been found in just the last few months. And specifically there are now at least 14 confirmed signals, with some of them being quite different. And one of the most famous ones is JPM J1839-10, a signal with a period of 22 minutes, but that apparently has been active for approximately 30 years. It just we've never really noticed it because it seems to emit radio emissions very slowly. In radio astronomy, this was one of the strangest discoveries in the last couple of years. Although it's this signal, GLEAMAX J1627-11, 5235 that basically kickstarted everything. This was the first signal discovered in 2018 with a pulse of 18 minutes. And once again also extremely high polarization of 95%. But even here some of these signals are also bizarre in their own way. For example, chime J1634 plus 44 seems to be speeding up, or basically seems to increase in frequency as opposed to what it should be doing, which is decreasing in frequency because its rotation should be slowing. And so here, because this is spinning faster and faster, it potentially is stealing a lot of material from the companion star, which is making it accelerate its rotation because of the transfer of the angular momentum. And so basically even here, quite a few of these signals possess very unique properties, and properties that are basically kind of difficult to explain. But I guess the biggest question is, okay, so what can this be? Is there any way for us to explain at least some of this? And what theories do scientists currently have? Well, right now there are basically two main ideas, and both, at least to some extent, make sense. Okay, so maybe these are slow-spinning magnetars, mostly because of these extremely magnetic conditions observed through polarization. And so here we will have a magnetar that might be spinning extremely slow, most likely because it was produced by some kind of a strange supernova that created an additional disk around it, which essentially acted like a kind of a brake, slowing it down to spin once every few minutes. In other words, it's a magnetar with an accretion disk. And so here, maybe, a slow-spinning magnetar that possesses an accretion disk could produce some kind of a slow emission of radio waves with extremely high polarization. Although, once again, this would not really explain why we don't really detect anything else here. Alternatively, these could also be very strange white dwarfs, or basically a type of a star that the Sun is going to become sometimes in the future. And surprisingly, this is one of the more accepted theories, because it seems to make more sense. And here, astronomers found at least two of these LPTs that seem to be definitely part of a binary system, in this case consisting of a white dwarf and an M-type star or a red dwarf. And in these systems, the magnetic field of the white dwarf interacts with the wind coming from the companion star that then generates bright radio pulses every time they orbit around each other. Or basically in this case, the period is actually the orbital period of two separate objects. And well, technically this would definitely make sense for some of these objects, but once again, not for this one. Here we would definitely see the red dwarf, or would at least see something. And so for all we know, this particular object might be creating its own new category. And so even though quite a few of these seem to be stable over decades and seem to produce relatively similar emissions, other ones are transients and only seem to appear for a few months before disappearing completely. And so a lot of these new radio discoveries are forcing astronomers to start rethinking certain models and rethinking everything we thought we knew about how radio signals are produced. Because here, by studying these signals, we're definitely learning about magnetic fields and their interaction with various objects, while also learning a little bit more about various stellar remnants and the evolution of stars in general, and especially stars in various binary systems. But I guess more exciting discoveries might come from some kind of new physics. Specifically, if some of these are indeed isolated neutron stars, here astronomers have to figure out what physical mechanisms seem to produce these signals, and where exactly they're getting all of this energy. And because for all we know, maybe these are not really neutron stars, but something a little bit more exotic like, for example, quark stars. Basically hypothetical star-like objects that seem to be made out of exotic matter. Or completely new, never before seen stellar remnants that require completely new explanations, which by the way is how neutron stars were discovered to begin with. The signals coming from them were so bizarre and so strange that they actually acquired completely new explanations that nobody considered before. And so something very similar could be happening here. But that means that right now we're basically at the tip of the iceberg when it comes to these discoveries. And as new telescopes become operational and add additional data to many of these archives, we're most likely going to discover even more of these objects all over the place. But at least for now, this mystery of the 37-minute radio signal is going to remain a mystery. Right now we have no idea exactly what this is, and trying to explain this as a magnetar or a white dwarf does not really make sense because there is just no evidence yet. The only evidence we have is that whatever produced these radio emissions, the radio waves here seem to have traveled through some extremely birefringent medium, or essentially space itself, that starts to act like a light prism. It essentially starts shifting the light in such a way that even though it's just vacuum, it starts to act like physical medium. That's actually one of the effects explained by the Einsteinian principles, and we've briefly discussed this in one of the previous videos in the description. And usually these types of media are produced by extremely dense objects like neutron stars, and of course magnetars. But, as I mentioned, it could also be something more exotic. With the other question of course being, why only 8 days? What could have happened during those 8 days that suddenly started producing this, and why did it then just disappear as suddenly as it appeared? Which means that we'll definitely come back and discuss this more in some of the future videos, because right now there's just no answers. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying a Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.